Hello everyone, and welcome back to Reverse Engineering Linux 32-bit applications. In this video, we are going to continue our discussion of stack buffer overflows. In a previous video, we had talked about the basics of stack buffer overflows and how it is that they're able to exist. And in this video, I want to walk you through an example application that might have a stack buffer overflow that you could exploit. So let's get started. So here I have a very simple application. I'm just going to open it up with gedit. It's my bufferOverflow.c. So it has the standard libraries included, standard IO, standard lib. I create my function called function that takes a single parameter that is a pointer to a string, which I called param. I create a local variable conjunction function. I create a local integer and I store the value of dead beef in it. I create a second local string, this one of length 10. Then I will use strcpy to copy param into local string 2. Now, we said, what's the problem with this? I only have 10 bytes. That's 9 bytes for the string plus a null terminating character. If I copy something longer than 9 characters into it, it's going to overflow. And that's a problem. And my function will return a value of 1. So here in my main method, I take a number of arguments from the command line, and that count is passed to me. And then my list of strings is passed in. Typically, we like to call that parameter argv. I once again define a couple of local variables, a local string called main function, or at least that's the value of it, and an integer that I store the value of 11223344 hex inside of. Then I will call function with argv1, the very first thing that was passed in, and I return 0. So we said that in general, where can I have a vulnerability? When there's a flaw in the software, and I've given the user control over what gets passed to the section of software that has that flaw. So in this case, there's a flaw in function, and I am passing in something that the user put in on the command line to it. So they have control over it, so then bad things can happen. So let's start by doing this. Let's start by compiling this application. Now there are a couple of ways that we could build this application. The easiest is just to use GCC. So I can say GCC 32, and it's bufferOverflow.c. If I do this, it gives me a warning, and it will tell me about a couple of things. It says implicit declaration of strcpy, incompatible implicit declaration of built-in function, and note include string.h or provide a declaration of strcpy. So it's just warning me about this stuff. We've talked about this before. By default, it's going to give me an executable called a.out, I can instead get a different executable like so. I can say, all right, please output this to buffer overflow. And now if I do an ls for buffer overflow, sure enough, here's my new executable. Okay, now what should be able to happen here? I should be able to run this executable and it should crash. So let's see if it does or not. So if I run buffer overflow and I'm going to give it, well, for starters, I'm just going to give it less than 10 A's. And it runs and nothing bad happens. Okay, so now what? What if I want to run it again, but this time I'm going to give it a lot of A's. So this is definitely going to overrun my buffer. And here it tells me that the program died. The core has been dumped. So I definitely got it to crash. Now the question is, did I get it to crash in such a way that I could redirect it? And that's not completely clear based on this. All right, so this application has crashed, but let's see how it's crashed and can I do something to make it crash in the exact way that I want it to crash. So we could go ahead and use one of our specialty debuggers like EDB. And again, if you don't know how to use it, you can try edb-help, and it will remind you of how to run this application. So I can attach to a process, and I can also run a program and give it some arguments. This can overcome things like little bugs in the mechanism where you can try to change those arguments later. So let's go ahead and have a look here, and we'll go ahead and run edb-run, and we're going to run buffer overflow, and we're going to pass it a whole bunch of A's. We're going to start there. We don't really need to watch the output, so I'll just pull it over to the side onto another screen. And now let's run our application. So here we are. Now before I go any further, I'm going to go ahead and analyze my different regions. And when I do that, now it's grouped together my functions. So here I am in my main function. And how do I know it's my main function? Well, I can see things like the ASCII value main function that was stored in my local variable. So let me go ahead and step ahead here. And once again, I'm going to move myself to the other side of the screen so that we can see the stack a little bit better. Okay, so I'm going to step I've loaded my effective address into ECX of my stack pointer plus 4. Here it is. You can see my stack is here. I'm going to round it off using an AND operation. And I am going to push a double word into this location, ECX minus 4. So here's ECX. I subtract 4 from that, and I should get somewhere in here. So let's see what happens when I do that. I'm going to push my EBP onto the stack, and I'm going to move my ESP to my EBP. So I'm saving that, if you will. I'm going to push ECX onto the stack. I'm going to subtract hex 14. I'm going to make some space. I'm going to move ECX to EAX. And now I'm calling into this main function. So the first thing I'm going to do is I'm going to move the memory location for main function into EBP minus 16, x10. So I should see this value appear in my stack. There it is, right here. Now I'm going to move 11223344 onto my stack. There it is, 11223344. I'm going to move EAX plus 4, what's pointed to by that, to EAX. I'm going to add 4 to EAX. And I'm going to move what's pointed to by EAX to EAX. And you'll notice that I have this pointer to this large ASCII value, a bunch of A's. I'm going to subtract C from my stack pointer. I'm going to push EAX. So I pushed on this value, and now I'm getting ready to call buffer overflow. So recall we talked about calling conventions. And we said if you're using cdecl, you're going to push those parameters onto the stack. Now we only have one parameter in this case. If I go back to my source code, I can remind you of how that looked. So here's my source code. I have the one parameter. It's a pointer, and it's been pushed onto the stack, and I'm getting ready to call function. So now I'm going to step into this function, and here we're going to have some standard things that happen. So it's going to push EBP onto the stack. It's going to move ESP to EBP, sort of a preamble, if you will, for these functions. I'm going to move EBP plus 8 to EAX. So once again, EAX is pointing to a address that has all these A's in it. I'm going to move EAX onto my stack. So let's see what happens there. Here we have our address on the stack. Here we have this value, which is now in EAX. Now I'm going to zero out EAX. And I'm going to move conjunction function to this location, which is, of course, on the stack. So here we have conjunction function, a pointer to that. And now I'm going to move dead beef onto the stack. Here it is, dead beef. I'm going to push this onto the stack, and it's the location of this value. And now what? Now I'm going to load the effective address of EBP minus hex 16 into EAX. There it is, FFD8E4B2. And now I'm going to push EAX onto the stack. So let me step forward again. And here we have this address on the stack. So let's recall our cdecal. Our cdecal says I push all of my arguments for a function onto the stack from right to left. So my second argument for strcpy was, in fact, right here. It's my source. My first argument is my destination. So here's my source, and here's my destination. Now this address is, of course, on the stack. So here's my stack, and it starts right about here. I'm just going to step over this function, and let's see what happens. Here I have my address, and if I look at my stack has been pretty much destroyed. So now what's going to happen? I am going to step over this, and now I'll step again. And here's something very interesting. It says call buffer overflow stack check fail. So you might think, well, what is that all about? What is this stack check fail? So I'll go ahead and step into that. And here you can see a little bit of this function. And what's it going to do? It's going to essentially say, hey, I noticed that you just polluted the stack. You just did something bad. And I don't like it. And it comes up and it tells me this function has died. This application has died, rather. Okay, so you might be thinking, well, okay, so I've successfully exploited this, perhaps. Now, what we'll find out in a future video is that on Linux, using the default compiler, the GNU compiler collection, GCC, it has a stack protector which will automatically be enabled that will prevent these attacks from happening. Right? And we'll talk a little bit more about that in a future video. But that's all that I had to talk about in this video. As a reminder, this video is one in a family of videos that we have here at Pen Tester Academy, where you can learn about everything you ever wanted to know related to information security. And I look forward to seeing you in this class and or another class here at Pen Tester Academy in the future. So I will see you then.